Welcome to Study Loop.
Our question says, a stunt driver wants to make his car jump over 8 cars parked side by side below a horizontal ramp, figure 46. And A, with what minimum speed must he drive off the horizontal ramp? The vertical height of the ramp is 1.5 meters above the cars, and the horizontal distance he must clear is 22 meters. If the ramp is now tilted, and then part B is, if the ramp is now tilted upward so that the takeoff angle is 7 degrees above the horizontal, what is the new minimum speed? Okay. Well, to solve this problem, we are going to consider the fact uh, that the origin of the coordinate system is going to be on the ground with the cars. Or I'm sorry, the choice of the origin system is going to be the location where the car leaves the ramp, and choose the upward position to be the positive y direction. So the location where the car leaves the ramp, or y of 0, is going to be equal to 0. And at the end of the flight over the 8 cars, the car must be at y equals minus 1.5 meters, because that's the height of the ramp. Okay, so I write here y equals minus 1.5 meters. And I also write the initial velocity in the y direction, which is 0. The acceleration in the y direction is negative gravity, okay? And then the total distance traveled in the x direction must be 22 meters to clear the cars. So now what we want to do is we want to find for part A the initial velocity, v of 0, okay? So I'll go ahead and write that down because that's what we're going to try to find. What is the initial velocity? Well, in order to do that, we are going to need an expression that contains initial velocity. Well, since all of the velocity is initially in the x direction, right? You can say that the distance that the car travels, which is x, is equal to v naught, right, times the time that it's in the air, okay? All right, well, there's v naught in that equation, okay? But we don't know the time. All right, so now we would need to figure out the time. Well, using equation 2-12b, which says that y is equal to y naught plus the initial velocity in the y direction times the time. Well, there's the time, which we need to find. Okay, is equal, or I'm sorry, plus 1/2 the acceleration of gravity, or the acceleration in the y direction, which is going to be gravity, times time squared. Okay, well, if we plug in what we know into this equation, as far as replacing, see here, we can replace or solve for time. Time is equal to x over v naught. So if we replace time in this equation with x over v naught, and if we replace the fact that y0 is equal to 0, and vy of 0 is equal to 0, right? If we replace all of that in the equation, we end up with y is equal to 1/2 a of y, which we can write as minus g, times t squared. But t is x over v naught squared. Okay, now let's solve for v naught. And if we solve for v naught, we end up finding that v naught is equal to the square root of minus g, right? Or I'm sorry, not minus g, the square root of y, or I'm sorry, no, right, minus g times x squared, times x squared, divided by 2 times y. Okay, and that's because you can rearrange this equation to equal x squared over 2 times, there's a negative sign here, times g, and then this is times 1 over v naught squared. Okay, So if you solve for V naught, this is what you get. And then if you plug in the known values for G, which is 9.8, you end up with minus 9.8 that's meters per second squared times x squared. X is 22 meters squared divided by 2 times y, which was minus 1.5. That's not a good one, right? Okay, so if we solve this out by plugging all of that into the calculator, we get this equals 39.76 meters per second. This is in meters. Goes off that, which is approximately 40 meters per second. Okay. Now, moving on for part B, if you recall, part B says to figure out what the new minimum speed would be if the ramp is now tilted so that the takeoff angle is 7 degrees above the horizontal. Okay, so let's open up a new page here, and we're going to be working on part B. So now we know that theta naught is equal to 7 degrees. And, well, because the velocity isn't in the horizontal direction, there is a horizontal and a vertical velocity, which are v of x is equal to v naught times cosine of theta naught. And vy is going to be v naught times the sine of theta naught. Okay, and again, we can use the same expression above, right? Where y of 0 is still equal to 0, except this time, for vy of 0, we now have v naught sine of theta naught. Okay, and this is multiplied by t. And on the previous page, t was equal to, if we go back to the previous page, t was equal to, I'm pointing to it here with this arrow, t was equal to x over v naught. Well, now v naught is our v of x, okay? So t is equal to, let's write it over here, x over v naught, which is, or v naught y, which is v naught sine theta. Or I'm sorry, vx, because we're talking about the time in the x direction. So it's v naught cosine theta. That's all in the denominator. Okay, so when we plug in time here, we're going to have to use that expression for our time. So this is going to be multiplied by x over v naught cosine theta naught. Okay, now added to this is going to have to be the same thing as before, 1/2 ayt squared, but as we know, this is 1/2 times minus g, which is minus 1/2 times g, times t squared, which is x, divided by v naught cos theta naught squared. Let's separate those there. Okay. All right, so now, once again, we want to solve for V naught, but before we do that, let's simplify some things. So we see that, I'm going to cancel these out here in red. We see that these two V naughts cancel, right? So that's convenient. Another thing we're going to see is that sine theta, here we have sine theta over cosine theta times x, right? So we're rewriting this, but sine theta over cosine theta is the same as tangent theta. So we have, well, we'll write the x out front. So instead of sine theta over cosine theta times x, we have x times tangent theta. Okay. And this is still minus 1/2. And then let's go ahead and write everything that we're trying to solve for on the outside, and then, or everything that we're not trying to solve for on the outside, right? So we have g times x squared, and then we have divided by cosine squared theta naught. And this is all multiplied by 1 over V naught squared. Okay, so let's start now trying to solve for V naught. So the first thing we can do is we can move the x tangent theta over to the other side and then multiply everything by -1 to get rid of that negative in front of the 1/2 g there. Okay, so let's do that. So we have, we'll put the V naught squared on this side of the equation, right? And then we have 1/2 g of x squared over cosine theta naught squared is equal to, and okay, so there's going to be a minus y over here, and then plus x tangent theta. Okay, well, now let's multiply the 1/2 over to the other side, or let's multiply 2 on each side to get rid of the 1/2, and then we need to multiply by the inverse of gx squared over cos squared theta. Oh, and this, I did not use correct notation here. Let me put some parentheses on the outside of this. The whole thing is squared. Cos squared theta, is the inverse of that, needs to be multiplied by each side. And then we can invert that whole thing to get V naught squared. So we're going to end up with V naught is equal to the square root of gx squared divided by, and this is 2 times x tangent theta that's tangent theta naught, right? And then that is minus y, subtract y from that, okay? And then you multiply all of that by cosine squared theta naught. Okay, so if you go in and for all the values now, you plug in the known values. So for g, you have 9.8 meters per second squared. For x, you have 22 meters. For theta naught, you have 7 degrees. And for y, if you go back to the first page here, for y, we have minus 1.5 meters. So if you plug in all of these known values, you'll find this comes out to equal 24 meters per second.